Hi my dear students, welcome back to the class. So far we were discussing about the practical applications of this chapter sets, isn't it? We discussed several practical situations and how we can solve or how we can impart the concept of sets into those practical applications have been discussed in the previous classes. In this class we are going to solve exercise 1.6, which deals with several interesting problems which is closely related to the practical life and that we can solve using sets. So the first question is, if x and y are two sets such that n of x is equal to 17, n of y is equal to 23 and n of x union y is equal to 38. Find number of elements in x intersection y. We know the result. N of x union y is equal to n of x plus n of y minus n of x intersection y, isn't it? Now we shall find n of x intersection y from this result, which is equal to n of x intersection y is equal to n of x plus n of y minus n of x union y. What is n of x here? T is equal to 17 plus what is n of y is here? 23 minus n of x union y, which is equal to 38. 17 plus 23 is equal to 40 minus 38 and the answer is 2. That's it, the question number 1. Now coming on to the second question. The question is that if x and y are two sets such that x union y has 18 elements, x has 8 elements, y has 15 elements, how many elements does x intersection y has? We are given with n of x union y is equal to 18 and n of x is equal to 8, n of y is equal to 15 and we are asked to find what is n of x intersection y, isn't it? We know that n of x intersection y is equal to n of x plus n of y minus n of x union y is equal to what is n of x? N of x is equal to 8 plus n of y is equal to 15 minus 18. So 23 minus 18 is equal to 5 will be the answer for n of x intersection y. So this is the answer of second question. Coming on to the third question, the question is that in a group of 400 people, 250 can speak Hindi, 200 can speak English. How many people can speak both Hindi and English? Note that, let H be the set of all people who can speak what? Hindi. Yes. And let E be the set of all people who can speak what? English. So H and E respectively denote the set of all people who can speak Hindi and E be the set of all people who can speak English. Now by the given condition n of H union E, that means the set of all elements who can either, the set of all people who can speak either Hindi or English, the number of such elements will be, number of such people will be definitely 400 because in each of the 400 people should speak at least one of the language in order to communicate. Okay. Now 250 can speak Hindi, which means that n of H will be what? 250. Now the next one, 200 can speak English, which means that n of E will be 200. We have to find n of H intersection E, isn't it? Now we know that n of H intersection E is nothing but n of H plus n of E minus n of H union E. It is equal to 250 plus 200 minus 400. Now 250 plus 200 is nothing but 450 minus 400 and the final answer will be what? 50, which means that 50 people can speak both Hindi and English. Coming on to the fourth question, the question is that if S and T are two sets such that S has 21 elements, T has 32 elements and S intersection T has 11 elements, how many elements does S union T has? We know that n of S union T, that is number of elements in S union T is nothing but number of elements in S plus number of elements in T minus number of elements in S intersection T, isn't it? Now given that n of S is equal to number of elements in S is equal to 21, n of T, is equal to 32, and also given that n of S intersection T is equal to 11. Now it is required to substitute all these quantities into this equation to get n of S union T. N of S union T is equal to 21 plus 32 minus n of S intersection T is 11. It is equal to 42. So the number of elements in S union T is nothing but 42. That's the end of fourth question. Now coming on to the fifth question of this chapter. Question is that if x and y are two sets such that x has 40 elements, it means that n of x is equal to 40. Now x union y has 60 elements, which means that n of x union y is equal to 60. X intersection y has 10 elements, which means that n of x intersection y is equal to 10. How many elements does y has? Which means that we have to find n of y, isn't it? Okay. Now we know the equation n of x union y is equal to n of x plus n of y minus n of x intersection y. We have to find out what is n of y. So we are going to isolate this quantity in the RHS and we are going to take all other quantities to the left hand side. So the equation will become n of x union y minus n of x plus n of x intersection y is equal to n of y. Okay. Therefore, we obtained an equation like this. Now we can substitute the quantities here. N of x union y is equal to 60 minus n of x is equal to 40 plus n of x intersection y is equal to 10, which is equal to n of y. What is n of y? We have to find it out. So it is n of y. Now 60 minus 40 is equal to 20 plus 10 is equal to 30. So n of y is equal to what? 30. So this is the number of elements in the set y. Now coming on to the sixth question. The question is that in a group of 70 people, 37 like coffee, 52 like tea, and each person like at least one of the drinks. How many people like both coffee and tea? So given that, let T denotes a set of people who likes tea, and let C be the set of people who likes coffee. Whenever you write or attempt to answer such questions for exam, just remember to name these two sets. Otherwise, the examiner or the evaluator will feel confused of your notation. So T and C will be like this, and by the given condition we have n of T union C is equal to 70 because there are 70 people and each person likes at least one of the drinks. Okay. Now 37 like coffee, which means that n of C is equal to what? 37. Now 52 like tea, which means that n of T is equal to 52. Now we have to find n of those who like both coffee and tea, which means that n of C intersection T have to be found out. Now by the given equation, we know the equation as n of C union T is equal to n of C plus n of T minus n of C union T, isn't it? Sorry, C intersection T, isn't it? Now applying all the quantities given to us into this equation, we get 70 is equal to 37 plus 52 minus n of C intersection T. Now we can easily find out n of C intersection T like this. N of C intersection T is equal to 37 plus 52 minus 70. It is equal to 89 minus 70. It equal to 19. So 19 people are there who likes both coffee as well as tea. Coming on to the seventh question. The question is that in a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only, not cricket? How many like tennis? So this is the question. So we can easily solve this. Let me first of all name. Let T denote set of all x such that x likes tennis. So T denote the set of all players who likes tennis, and let C is equal to set of all x such that x likes cricket. So before you attempt any similar question, try to name the set like this so that your answer will be more precise and evaluator will never feel any confusion while valuing your paper. Now coming on to the question, 40 like cricket, which means that n of C is equal to 40. Right? Now 10 like both cricket and tennis, which means that n of C intersection T is equal to 10. How many like tennis only, not cricket? Let it be there. We shall solve the second part first. How many like tennis? So we have to find n of T. Also note that there are 65 people and each one likes at least one of the games. So n of C union T is nothing but what is 65. Therefore n of, we know that the equation n of C union T is equal to n of T plus n of C minus n of C intersection T. Okay, now we shall substitute the quantities. 65 is equal to what is n of T? N of T is n of T, we have to find out n of T. Let it be there. N of T plus what is n of C? It is equal to 40 minus what is the intersection? It is equal to 10. Therefore 65 is equal to n of T plus 30. So therefore n of T is equal to 65 minus 30 equal to 35. So that is the answer for the second part. How many like tennis? Now the first part. How many like tennis only, not cricket? Which means that we have to find out n of T minus C, isn't it? Tennis not but cricket. Only tennis, not cricket. That is what we call the difference of two sets, isn't it? For that we have to draw the Venn diagram. Let us draw the Venn diagram like this. Let this be the first circle denote C and the second circle denote T. And we know that T minus C is this area, isn't it? Also we can see that T minus C union T intersection C is equal to what? T. See, T minus C is this area, T intersection C is this area, and the union gives the full circle which is T. Also note that T minus C intersection T intersection C is equal to 5. So this is that T intersection C intersection T minus C, which is disjoint, isn't it? Therefore we have n of T minus C plus n of T intersection C is equal to n of T. Since രണ്ട് disjoint സെറ്റുകളുടെ യൂണിയൻ T ആവുകയും intersection, disjoint means 5, so the intersection 5 ആവുകയും the number of elements will be the sum of elements in each individual cell. We have learned it in the previous class. So we can easily substitute the things n of T intersection T, C and n of T here to evaluate the required thing. So n of T minus C plus what is n of T intersection C? It is equal to 10. 10 is equal to what is n of T? N of T is equal to, we have evaluated n of T equal to 35. Therefore n of T minus C is equal to 35 minus 10 is equal to 25. Therefore there are 25 people who likes tennis only, not cricket. Coming on to question number 8 of your textbook, the question is that in a committee 50 people speak French, 20 speak Spanish and 10 speak both Spanish and French. How many speak at least one of these two languages? This is the question. We shall make two sets from the beginning itself. Let F be the set of all x such that x speaks what? French, and let S is equal to set of all x such that x speaks Spanish. So this is the two sets F and S. Now by the given condition 50 people speak French, which means that n of F is equal to what? 50. 20 speak Spanish, which means that n of S is equal to 20. And 10 speak both Spanish and French, which means that n of F intersection S is equal to 10. How many speak at least one of these two languages? So this is the question. How many speak at least one of these two languages? So we have to find N of F union S. Not that the word at least reminds us to find union, which means that either in one of the sets. Also note that here we have what? Both and, which means that intersection. So note these words in the question so that you can easily solve any problems very well. Now we know N of F union S is nothing but N of F plus N of S minus N of F intersection S. It is equal to, what is N of F? It is equal to 50 plus N of S is equal to 20 minus, what is the intersection? So 10. So this will be the answer. 70 minus 10 is equal to 60. Therefore N of F union S is equal to 60, which means that at least 60 people speak at least one of the languages, French or Spanish. So this is the end of exercise 1.6. I hope you are already clear with the concept, underlying concept behind each and every problems we have discussed in this session. So if you have any doubts, just clarify it with me. And in the next session, we are going to begin the new chapter, relations and function. So till the next class, wait for the next class. Bye bye.